This is Mark Fielding of Solarboat. Assembly and load testing of structural pallet frames. First, select 2 pallets of the same type and size. We use stringer pallets for structural assemblies. Three or 4 stringers per pallet, equally spaced. Fit them together on the floor, end to end. A block pallet is no good for structure, but good for flitch boards. We are going to use the flitch boards to join 2 stringer pallets together. Let's cut some boards from a block pallet. Cut deck and skid boards off non-structural block pallets or similar. Use a handheld circular saw with the blade set for a shallow cut. Turn over the pallet to cut some deck boards. Make your cuts as close as possible to the nails without hitting them. This is to achieve the longest possible flitch boards. We only need 2 flitch boards per stringer joint. So for a 3 stringer pallet assembly, that is a total of 6 flitches. Now before we fix our flitch boards, we need to make a small adjustment. These 3 stringer pallets have double skid boards, so we need to remove these edge skid boards in order to provide space for our nail gun. We use a crowbar and hammer, but any demolition bar method will do. Remember to wear safety gear, earmuffs, good boots, etc. Be careful of those sharp nails. These spare skid boards can be cut into more flitch boards later. Now armed with nail gun and flitch boards, align the 2 stringer pallets in a direct line. Set a flitch board to one side of the first joint, and holding it in place, shoot 5 nails into each end. 5 nails in a stretched dice pattern, like the 5 dots on a dice. Now set a flitch board on the other side of the first joint, and repeat the fixing process. Use 65mm annular grooved galvanized nails for 50mm stringers, or use 50mm annular grooved galvanized nails for 35mm stringers. Use F-clamps if pallets are not quite aligned. 2 F-clamps for each joint are good. Use sash clamps to keep the 2 pallets close together. Now repeat the double flitch board joint on the other edge. Our nail gun was an old pass load air gun with a noisy compressor. A pass load gas framing nailer or New Zealand made air bow would be better. Now to finish the central stringer joint using the same method. This is where those F-clamps come in handy. It's a lot of fun using a framing nailer gun. Now the structural pallet frame is complete. It could be used as a wall panel in this simple form. But first, we need to test its strength. Turn over the panel and rest it on 2 blocks of the same height. These blocks emulate the support points at each end of the panel. A wall panel spans between its bottom and top plate. Our load test will emulate a potential wind load on the wall. With a known wind load for our site location of say 44 meters per second, that is high wind zone, we use weights or mass to exert an equivalent force on the wall. But we need to know what the conversion is, wind speed to force. Wind load is measured in newtons per meter squared or pascals. Divide by 1,000 to get kilopascals. Use this website link for converting a known wind load to kilopascals. Thus, a wind speed of 44 meters per second equals 968,000 newtons per meter squared, or 0.968 kilopascals. Firstly though, let's measure the center height of the unloaded panel and record the measurement with an identification board. We use a standard steel metric ruler. The type that starts with 0 right at the edge. The identification board and ruler is photographed for the record. Okay, that measures 265 millimeters unloaded. Here is a photo record of an unloaded panel measurement. Now it's time to apply our test load to the pallet assembly panel. So now we need to convert force to mass, which is actually quite easy, because 1 kilopascal of force is roughly equivalent to 100 kilograms of mass. So we load the panel joint with the number of kilograms of mass that equals our wind load. Now, as 1 litre of water equals 1 kilogram of mass, we can simply use water for weight. Now 100 kilograms, 120 kilograms, 140 kilograms now, and another 10 litre flagon to bring it up to 150 kilograms. $150 kilograms of mass is roughly equal to 1.5 kilopascals of force, or 1500 newtons per meter squared, which we read off this graph as equal to 50 meters per second wind speed. Which is equivalent to very high wind speed in New Zealand. But now we need to check what sort of sag this panel has under load, so we use our ruler again to measure the loaded deflection. Okay, that reads 259 millimeters now, and we take another photo. To find the deflection in millimeters, we subtract this from the first number. 265 millimeters minus 259 millimeters equals 6 millimeters deflection under load. But what does that mean? Well, it gives us a value to compare to an acceptable value. In engineering, an acceptable deflection is found by dividing span over 300. Span is expressed as capital L, so we need capital L divided by 300. Our capital L, or span, is 2.2 meters between supports. So 2.2 meters divided by 300 equals 0.0073 meters, or 7.3 millimeters. And our measured deflection was 6 millimeters, so just within limits. so we can be confident this wall panel will perform without failure, even in very high wind speeds of 50 meters per second. Every structural panel made this way must be tested thus, whether for floor, wall or roof structure, so that we can be confident our pallet building is structurally safe. For further information, please read the ebook Building with Pallets. Thank you for watching.